afternoon, guys. This is your lesson for the day. Hopefully it goes okay with the video. I'll try not to talk too fast, but if you need to stop the video and catch up, just ask Mrs. Walker to stop it or pause it and rewind it if you need to. So this lesson is going to take 2 days. We're going to start today. I'm just going to introduce 3 laws of logarithms to you, and then tomorrow we're going to work with them in a little bit more detail. You'll have an opportunity to get some help if you don't understand it. But they are fairly straightforward, and they are based on the exponent laws. So there's some similarity between these laws and the exponent laws. So first of all, if you take out your formula sheet, this is in your notes, but I put it in your sheet just to look at it. On your formula sheet, under the logarithm section, so we have here's our definition of a logarithm. Here's our change of base law. And the laws of logarithms are these 3 things that we're looking at here. Okay? We have a power law or a product law, a quotient law, and a power law. The product law involves multiplication of logs, the quotient law involves division of logs, and the power law involves raising something, it involves exponents. So we're going to work with that, and I'm going to show you just basically how to use those particular laws. So we'll start with the product law of logarithms. So the product law, although it's on your formula sheet this way, so what it says is it says log base b, so that means any base, of m times n. So if your argument is m is a number times a number, then that is equivalent to log base b of m plus log base b of n. And so you can take, if you've got a number in here, m times n, you can split it up and write it as 2 separate logs that you're adding. The thing is the way that law is written on your formula sheet, it's a little bit misleading, because in actual fact, the way that you use that law is actually the other way around. You're usually doing this. Taking log base b of one number, and if you're adding it to a log with the same base of another number, then that means you can simplify your calculation by multiplying the m and the n together and then just taking that log. So I'll do a couple quick examples to show how that works, and then we'll look at the quotient law. So we have log base 2 of 16 plus log base 2 of 8. So they're both base 2. Okay, both base 2. So the bases have to be the same for you to be able to do this. So write them as a single logarithm. So when you're writing something as a single logarithm, that means use the laws to simplify. So what we're going to do here is we have log base 2, and then what we have in here is the 16 will be m, and the 8 will be n. So what we have is log base 2 of 16 times 8. So carry out that multiplication. Log base 2, 16 times 8 is 128. So then you're solving log base 2 of 128, which you can do 2 ways. You can do change of base, so that's log 128 divided by log 2, and that'll give you 7, or use the definition of a logarithm. 2 to what power gives you 128, and that would be x equals 7. So for example B here, we could do the same thing. They're both base 3. Both base 3. 27 is our m, and 3 is our n. So we're going to write this as log base 3 of 27 times 3. And notice when we do it, we go from having 2 logarithmic expressions to having 1. That's the point of the log. So this is log base 3 of 27 times 3, which is 81. So then you can use your change of base to evaluate that. Log 81 divided by log 3, and that should give you 4. Or you can use your definition of a logarithm. 3 to what power gives you 81. So 3 to the power of x gives me 3. 3 to the power of x is equal to 81, which is 3 to the power of 4. So x equals 4. I skipped that step over here. This is 2 to the power of x equals 2 to the power of 6. Okay, so hopefully pretty straightforward. The quotient law quotient means divide, so it works with division. So again, on your formula sheet, it's on there as log base b of m divided by n is equivalent to log base b of m minus log base b of n. But you usually use it the other way around. So usually you'll be taking two logarithmic expressions that you're subtracting and writing them as a single logarithmic expression where you simply divide the arguments instead of having to subtract two logarithmic expressions. So again, you're looking for the same base, and we're working with the same numbers here. All I did here was change it from addition to subtraction. So to write it as a single logarithm, again, that means use your laws of logarithms. So this is log base 2 of 16 divided by 8, which is log base 2 of 2, which you can solve, that's an identity, x equals 1. Or you can do log 2 divided by log 2, and obviously that equals 1. Or the definition of a logarithm, which says 2 to what power gives me 2, and obviously in there x equals 1. So we'll try it for part B. Log base 3 of 27 divided by 3. So log base 3 of 9. So I can do change of base. Log 9 divided by log 3. That gives me 2. Or 3 to what power gives me 9? 3 to the power of x equals 9, which is 3 to the power of 2, so x equals 2. Okay, so there is a question on the next page that is a your turn question for you to do. So I'll ask Mrs. Walker to stop the video here and give you about 5 minutes or so at the most to finish those two questions. And then when you start the video up again, I'll put the answers to that particular question on there. Okay. Okay, so we're going to look at combining, doing a couple examples where we're combining both addition and subtraction, like for the power law and the quotient law. And basically, the easiest thing to do here is just start from the left and work your way across. So the first one is pretty straightforward. That's just subtraction. So we're going to write that as log base 2 of 12 over 3, which gives me log base 2 of 4. So that's log 4 over log 2, so that equals 2. For part B, we'll group the addition together and we'll get an expression for that. So we get log base 6 of 9 times 8 minus log base 6 of 2. So that's log base 6 of 72 minus log base 6 of 2. Log base 6 of 72 over 2. So that's log base 6 of 36. So log 36 divided by log 2 equals 2. I showed a lot more work there than you need to show. I'm just trying to show you where all the numbers are coming from. So more typically the work that you'd show, I'll show here in C. You know, we log base 6 of 9 and log base 6 of 4 together. So I'm going to take my 9 and my 4 and multiply them. So that gives me log base 6 of 36 minus log base 6 of 6. So I didn't actually show multiplying 9 and 4. I can tell, if you've done this, whether or not you've multiplied. And then log base 6 of 36 over 6 is equal to log base 6 of 6, which is simply 1. Don't freak out if there's fractions. You're just going to end up having to multiply or divide it. So log, these are all base 10. So we have log of 2 times 10, or 20, minus log of 1 over 5. So then that's division. So we're going to do log base 10 of 20 divided by 1 over 5. So that's the same thing as log 20 times 5, right? 20 divided 20 by 1 over 5. 1 over 5 is 0.2. Log 20 divided by 0.2. So that gives you log 100. And log 100, if you plug that right into your calculator, it's just 2. We can root them even with subtraction. So we've got log 25 minus log 1/2. So that's going to give us log 25 divided by 1/2, which is 0.5, minus log 5. So 25 divided by 5, 0.5 is 50. So we have log 50 minus log 5, which gives me log 50 divided by 5, or log 10, which is just 1. Log base 10 of 3 plus log base 10 of 4. So that's going to give me log base 10 of 12 plus log 1/2 plus log 1/6. So this is log, and I can actually just, these are all additions, so I'm just going to multiply them all. 12 times 1/2 times 1 over 6. So that gives me log of 12 over 12. That gives me log 1, which is 0. Okay. All right, so on to the next page. Again, you can stop or pause the video if you need more time. So we're going to use the laws of logarithms to write log base x of 10 plus log base x of 75 minus log, in brackets, log base x of 2 plus log base x of 3 is a single logarithm. So we can't, all we can do is write a single logarithm. We can't evaluate it because we don't know what the base is, but we know the bases are the same. Then eventually we're going to evaluate it if we give a value to the base. So brackets, you always do what's in the brackets first. So we'll leave the log base x of 10 plus log base x of 75, and we're going to subtract off log base x of 6, because this is addition, so it's 2 times 3. Then we can go 10 times 75. So I'm going to do this a little bit differently. I'm going to skip some steps. So we're multiplying 10 and 20 and 75, but then we're dividing by 6. Because this is adding, these two are adding, so we're going to multiply, and then we're going to divide by 6, because that one's subtracting. So the step I'm skipping in there is log x of 750 minus log x of 6. That's going to give me log x of 750 over 6. I'm basically taking those steps and putting them together in this one. So I have 10 times 75 divided by 6, which gives me 125. So log base x of 125, and I've written it as a single logarithm. Now I want to evaluate it if x equals 5. So I want to know log base 5 of 125, what does that equal? So I'm just going to try and find that. I'll call that y. So 5 to what power gives me 125? 125 is 5 to the 3, so x equals 3. Okay, and the last law of logarithms is the power law. Power law. So the power law, just on your formula sheet here, I just need to go back. I'll just grab a formula sheet here. Just bear with me here. Just want to make sure I got the right format. So this says, it says that log base b, I don't want the bracket there. It's good. Log base b of m to the power works the other way. Works the other way as well. So just to illustrate, write the following in the formula. So we're using the power law. So we have log base 10 of x, and the x has an exponent of 10 on it. So we bring the 10 in front. So this just becomes 10 times log x. Log square root of x. Well, that's equal to log times x to the 1/2. The square root is written as an exponent 1/2. So then this becomes 1/2 times log x. So we'll carry on. Now we've got it, we're going the other way. Okay, so we have a coefficient, and we want to write our coefficient as an exponent. Okay, so that's it's going backwards. So the 5 just becomes an exponent on x. So 5 times log x becomes log base 10 of x to the power 5. The negative 1/2 goes out the front onto the, it becomes an exponent on the x. So we get log base 10 of x to the power of negative 1/3. We'll do one more example, and then I have a your turn question to do, and then I'll give you some text questions to practice. Tomorrow we're going to work on more complicated questions, putting all three laws together in the same kind of question, and then just looking at different ways that we can utilize these laws. Okay, so we want to write, again, we're going to write it in the format where we change an exponent to a coefficient, and then we're going to evaluate. So this will become 2 times log base 2 of 8. Okay, so we're going to keep the 2 there. We want to evaluate log 8 divided by log 2. So we can use our change of base there. That becomes 2 times 3, and the answer to that one is 6. If we look at this, we already have a coefficient of 6. We're going to move that 3 in front. So what we end up with is we're going to have, so we need to move the 3, and then the 3 gets multiplied to the 6. So we get 6 times 3 times log base 49 of 7. So that's 18 times log 7 divided by log 49. Log 7 divided by log 49 is 1/2. So it's 18 times 0.5, or 9. Okay, C is a little bit more complicated because we have a radical, and that's the cube root. So we're first going to start by rewriting that cube root. So we have log base 49 of the cube root of 7. Cube root can be written as an exponent of 1/3. So 7 to the power of 1/3 is the same thing as the cube root of 7. So then I'm going to bring that 1/3 off of the 7 and multiply it to the 6. Then I've got times log base 49 of 7. So 6 times 1/3 is 2. And that's times log 7 divided by log 49. So that's 2 times 0.5, or 1. And n times log base 6 of 6. So that's n times log 6 divided by log 6, which is n times 1, which is just n. So you can complete these 4 your turn questions. And then in your textbook, I'm going to have you complete or take a look at your assignment, and you should have lots of time to finish this. It's been a fairly short lesson. Page 446 to page 447, numbers 1 to 16. And then we'll do a little bit more with this tomorrow. So I'm just going to put the answers to those your turn questions, and then you can have the rest of the class to work on your assignments. And I hope you have a good evening, and I'll see you tomorrow.